This video will show you one way to deal with nonlinear trends in your linear regression. Linearity is the most important assumption of regression, and it is generally checked by a residual plot, as we discussed in a previous video. In this residual plot, I see a definite smile. I see a curvilinear relationship. This tells me my linearity assumption is violated. This data that I'm analyzing asks the question, how does GPA affect math scores? I've centered the variable as you're supposed to do, and I've regressed on math scores and saw the residual plot we saw. Oftentimes, when I see a smile or a frown, as I do here, that can be resolved by squaring one of my independent variables and plugging both the linear and squared term into my regression. In this case, the choice is easy since I have only one x variable, one independent variable in my regression. I will square my GPA-centered variable. So I'll go to Transform, Compute Variable, Reset. I'll call my target variable GPA-centered underscore squared. I will put in GPA centered and multiply it by itself. So I'm squaring that term. Let's paste that code, find my syntax, run it. I have a new variable in my data set called GPA centered squared. 0.54 does indeed result in 0.29 if you square it. And that's true for all these variables, so it worked as I expected to. And now I'm going to run my regression. I go to Analyze, Regression Linear, Reset, put in my dependent variable as normal, put in my centered variable, and then the squared term on top of that. Create my plot, putting the residual in the y, predicted in the x, paste the code, find the syntax, and look, my residual plot looks a lot better. I do not see any smiles or frowns. I've resolved the nonlinear relationship in my data, and now I can trust